ladies and gentlemen. So today we're going to be learning about 6.4, transforming piecewise functions. So today we're going to be looking at vertically and horizontally translating a piecewise function, so moving it up, down, left, or right. And then we're going to look at reflecting piecewise functions across the x and y axes, and then vertically and horizontally stretch compressing a piecewise function. So you'll notice that this really is kind of a flashback to Unit 1 from the very beginning of the school year, but we saved this for Semester 2, and this is the only transformations lesson we save for a different unit because of the fact that this deals with piecewise functions, and we just felt like that might have been too much to do all at once in the beginning, because we hadn't learned about piecewise functions yet. So here we are doing transformations in Semester 2 and looking at transformations with piecewise functions. So first, let's review some of the things that we had talked about in the beginning of the school year, just transformations on a single function and not so much on piecewise functions. So when we look at this warm-up problem for number 1, it says write the equation if f of x is vertically stretched by a factor of 3. Remember that a vertical stretch is something that is going to occur outside any grouping symbol, right? Because it's going to affect all the y pieces of the graph. So we are going to write a new function. I'm going to call it g of x equals. So I need to take this original function and I need to vertically stretch it by a factor of 3, meaning I need to make it 3 times as tall, if you will. The way we do that is I'm just going to do 3 times, and then in the parentheses, I will write down the original function. Because I have inside the parentheses the original function, this multiplied by 3 outside that function, so that means this 3 multiplied outside the function is causing that vertical stretch by a factor of 3, because it's going to make all of our values 3 times as large. Looking at the next one, write the equation if f of x is reflected across the x-axis. When something is reflected across the x-axis, that is a vertical transformation, because if this is my x-axis and I had something that was up here and I reflected over, that is a vertical movement. So similarly to how we did the last one, we need to multiply this function by something on the outside of a grouping symbol that's going to cause the vertical reflection. Well, the reflection happens because all of our numbers that were once positive become negative, or vice versa. So that means I'm multiplying everything by -1. Yes, we could simplify these. I could multiply the -1 in, but I really want to emphasize the location of these numbers and how the location of those numbers are having the effect of this transformation. Next one, write the equation if f of x is horizontally translated 5 units right. Well, remember, anything that's dealing with the graph horizontally is affecting our x values. And in my class, we always use the phrase of x is always lies. So if we're really going to the right 5 units, our equation is not going to say x plus 5. Instead, it's going to say x minus 5. And so what that looks like for us is all of our original x's in this equation are going to represent this transformation, because this is a horizontal transformation which is directly affecting our x values. So I'll have 3 parentheses x minus 5 close parentheses squared plus 4 parentheses x minus 5 close parentheses, and then -4. So notice that everywhere there was originally just an x variable in my original equation, I replaced with the x minus 5 to represent this transformation of going to the right 5 units. So this process that we just went through with these 3 problems are what we're going to be seeing in the lesson today. Something that could be helpful to remind you with transforming functions and how that affects our functions is this table here. A horizontal translation means you're replacing the x variable itself with whatever that transformation is. The vertical translations, moving it up or down, you won't see replacing the x variable. Instead, it would be added or subtracted on the end of the function. Reflection across the y-axis replaces the x variable with a -x. Reflection across the x-axis multiplies the original function by a -1. horizontal stretch or compression replaces the original x variable with whatever that transformation is, and a vertical stretch or compression multiplies the entire original function by that value. Now, there's something we have to be cautious with when talking about transforming piecewise functions, because piecewise functions have inequalities attached to each piece of the function. So when transforming these functions, there are three things that are going to affect those intervals or those inequalities. The first is a horizontal translation. The second is a horizontal stretch or compression. And last is a reflection over the y-axis. Recognize that the three things that these all have the one thing that these three items all have in common is that they're horizontal transformations, and that's because these transformations directly affect your x values, and they need to directly affect all x values in the original piecewise function.